Welcome back to the Automation Podcast. My name is Shawn, and this week on the show, I meet up with Berger from Siemens to learn about their Siemens motor control devices, SIMOCODE. Mark, thank you for coming back on the show. I'm excited to learn about SIMOCODE, which I know nothing about. But before we jump into your presentation and demonstration, could you first tell us a little bit about yourself and then tell us about this product?
Sure. I sure appreciate your time, Shawn, and thanks for letting me come back. So, my name is Berger. I'm an applications consultant for the target market management out here in the West and the Central U.S. I'm part of a team of 5 guys, and our main tasks is for cross the line starters, soft starters. We are the technical arm for anything that has smarts to motor management systems. And then our communication protocols that we help with are Aussie, IO-Link, and then we do safety relays, not safety PLCs, but safety relays. And we assist and help our sales force throughout the United States. As I stated, there's 5 of us. So, and I've been with Siemens just past my 17-year mark. And prior to that, I was a controls engineer for the shuttle boosters for the shuttles out there many years ago. So I appreciate the opportunity for this. And if you don't mind, I'll kind of dive into it. Is that all right?
Yeah, no, it's great having a rocket scientist on the show.
Well, I missed that era, but I truly love the job I have now and thoroughly enjoy it. And I'm grateful for the opportunity to cover this today. So, Semicode, where does it come from? Of course, everybody that I introduce this product to always ask, where's the name come from? Well, if you've been with Siemens and worked with them long enough, they always put SI in front of everything. So Simation, Simotion, and this doesn't discount it either here. We put SI in front of it, and it stands for Siemens Motor Control Device. So our topic today is going to just focus in on cross the line starters. There's, in a general sense, you have 3 ways to start a motor: cross the line, soft start, and then VFD, variable frequency drive. And so the soft starts and variable frequency drives already have an innate intelligence built in to give you a list of trips and what faults may have happened, some intelligence to help you control the motor with different control schemes and so forth. But across the line starter, NEMA or IEC, really has no intelligence in it other than maybe an auxiliary contact that tells you that the 3 phases are pulled in. And that's about it. So what this product does is it gives a relatively unknowledgeable starter, meaning a cross the line starter, it gives it intelligence so that you can use it and learn from it and measure things and so forth. And I'll show you a little deeper dive with that today. So with the Simicode, out of the gate, it is your overload. You will not need another solid state overload. This is the Siemens line for smart overloads, and that's what we call it, is a smart overload, or we call it a motor management system. But it will help you monitor. It'll monitor how many times the motor turned on, how many times it turned off. It'll give you up to 20 trips with a 21st being active, and it will time and date stamp them. So if you have an overload or phase loss or phase imbalance and so forth. And then it does all types of control. So again, we've partnered the Simicodes with our soft starts before for some applications, and we've partnered with them with our breakers, but for some very special applications. But the control part is mostly with this is a starter, reversing or non-reversing application, or maybe even a 2-speed motor. So we call our motor application requirements is that we say that we're going to monitor the motor, we're going to control the motor, and then we're going to protect it. But that protect also extends not just from the motor. I hope that you understand at the conclusion of this presentation that you'll see that we want to protect the entire process that the motor turns. We want to protect that gearbox or that fan or that pump and be able to give diagnostics to help those who are using that equipment to react quickly and be able to know what they need to do to get it back up and running or to prolong its life and maintenance applications and preventive maintenance applications and so forth. So with that little tri-circle, we call this the motor management system. And this is what SIMOCODE is a motor management system. Now, let's talk about controls. What kind of controls can the SIMOCODE do for you? Well, it can do all types of stuff. It can do run permissives. It can do local control, forward and reverse, 2-wire, 3-wire, local and remote. For our application today, local means that you're standing near the motor, and remote means that you're in some type of control room and you're looking at, 4 or 5 pieces of, or 4 or 5 glasses of screens controlling a big plant, and you need to have all the information you can from that pump or that fan or that conveyor belt. 2-wire system, 3-wire, and then again remote, and then handoff auto. So we can do all different types of controls. SIMOCODE is very flexible and very easy to start and to get it running and to be able to apply any types of forms of controls that you may see fit at your plant. To kind of fall back on the old ways, I've been around in this business for quite a few years, but back in the day we had a simple handoff auto start stop station for a traditional full voltage non-reversing motor, and that could be attached again to a fan or a conveyor or a pump. And then you had with the control system in a big gray boxes, and you had all the wiring coming out and so forth. And you may had some hand wired logic in the motor control bucket or the motor control cabinet. And then of course you had your protection. In the old days when we were still using abacuses, we had the motor heaters, which were bimetallic metal pieces of metal for your overloads. But now everybody's using solid state motor overloads. But this is a standard handoff auto in the off position motor starter that you would encounter in multiple plants throughout the nation. You can see that there's a PLC output so that when it goes to auto, it will turn on the motor being controlled by the DCS system or the PLC. And then you see that you have a sealing circuit right here, which is a auxiliary contact that would be with the NEMA starter or the IEC contactor. And this is me traveling the United States and doing this job. Multiple ways of calling this. Some guys call this the interlock. Some call this a sealing circuit. Some guys call it a maintainer. I've heard all different types of terminology for this. And then, of course, you have the overload here that would disrupt if something had happened with the motor in an overload capacity. But notice that the main cabinet still has all the logic, has the software, and it's doing all the monitoring. But then out in the remote cabinet, you might have some pilot devices. You may have a CT measuring something, and then, of course, your overload, and then some your hardwired logic like this HOA. So if we continue with that little bit of laying out the logic and the hardwiring, if we kind of build a little bill of material, you have the opportunity to bring in the closing. You've got the sealing circuit here, which is an additional contact that needs to be wired in. And then again, if somebody kind of says to their mind, when I think of a contact, that can be a trouble point for troubleshooting to verify that if this contactor has failed, then the motor, when they push start, won't stay maintained and run. So there's the troubleshooting point. And then there's an overload, of course, another contactor that comes in. And bear in mind, we've got input, we've got out here is that we've got analog input cards, digital ins, digital outs that you have to tie for one motor. And again, this is just a general overview. The 300 feet from the main cabinet, which we back in the day in some of my places we called MTAs or Marshall Terminal Assemblies, that 300 feet is just a generic measurement that we've done at different places. And we're just trying to show you the impact of what all the wiring does.
If you're listening and not watching, I mean, you end up for this one motor starter logic, hardwiring it to the PLC, you're using a lot of I/O.
Correct. Yep. And then that I/O takes up places. That's terminal blocks. So you're landing a lot of stuff for just one simple turn on and off motor. But this is what we did, us seasoned individuals, what we did back in the day. And then notice here that we've put a CT in so we could see the current, bringing it in as an analog input. And then here's kind of the bill of material. So 3 digital ins, 1 digital out, 1 analog in, extra starter contactors that I spoke of with the maintain or sealing circuit, current transducer, transformer, whichever, 3,000 feet of wire. And again, this is a generic overview. And then associated cable tray and conduit to get it from the facility outside into interiorly. So what do you get for all that? Really, you don't get much. You get a status that that contactor's pulled in, and that's about it. But if you're, let's say we're doing a conveyor belt, what do we use to, if somebody's sitting in a room with no windows, they can't see the facility other than what they see at their panes of glass or their monitors, what do they use for that indication that everything's running just fine? So a case in a conveyor belt, your coupler, your Lovejoy coupler might have sheared, the motor's turning, so everything's fine because he sees current flowing. But is it truly turning the application that you've connected that motor to? So let's say that that Lovejoy coupler sheared and the motor's turning fine, the operator's sitting there happy-go-lucky, but then what do you do for feedback to verify that that entire belt or that entire conveyor is moving? So some guys in the applications that are listening today, they do speed sensors,
Mhm.
which they would put on the head pulley or depending on where they wanted to notice it. But then also they could set some limits on the current draw that if it's unloaded, you could see that the current's maybe at 20% of full load amps or
Mhm.
so forth and so on. And that would give them some indications. But really, with a starter, you don't have any real intelligence telling you exactly how things are going at the motor and if it's running okay. So, with that said, a little quick picture. There's some applications of all that wiring, and I'm exaggerating a little bit for a point, but the project on the left, that was an actual application that came out here in the West that I was a part of back in 2002 and so forth. So this is quite interesting of to just make a point of all the wiring and so forth that we had to encounter, or we still to this day encounter at some plants.
How many terminals on the left? It looks like 300 if I were to guess, or 300 to
Yeah,
400. What would you say?
Y- Yeah, I'd say 400 easily. Understanding that this is a motor control center, this is
Mhm.
where the field wiring is
Oh
landing,
my
and then
word.
all this big cabling is going into individual motor controls buckets.
That is a
So
lot
this
of
is,
terminals and a
yeah,
lot
and
of
that's a,
wiring
yeah, and there's 3 or 4 electricians sitting there going in there and working on it. And then
and
think
a
of the
lot
loop
of testing.
checks.
Yeah.
Yeah, the loop checks. That's
Oh,
spending days in there saying, "Okay, push this, go," so
yep.
forth and so on. So again, I'm exaggerating just a little bit, but this is an actual application just to make a point of how great now with all the bus systems that we have and so forth. So if we replace with a field bus, and initially in the back in the seasoned individuals, we started working with RS 232,
Mhm.
RS 485. For Siemens, the RS 485 communication protocols Profi bus. You may encounter data highway, Modbus RTU, and so forth. But this is the field bus started to help reduce some of that, all that wiring. But also that it did is it gave some opportunity to move some things out into the remote cabinets too, because you started having bandwidth to where you could bring in multiple points of data with the same piece of wire and get statuses and so forth. So we reduced a lot of the wiring, and I kind of comically joke a little bit with some of the younger guys that are coming into this field that they have it so good.
Mhm.
Spending a day trying to get a RS-232 and baud rate and all that other stuff, or RS-485 working properly, was that's probably why I've lost most of my hair. So anyway, moving along. So with that stated, introducing the field bus, and then you kind of see a trend where things are moving out, where you're getting remote control, flexible logic, not just hardware logic, and then remote I/O and pilot devices, of course, and then motor protection, which and nowadays it's switched to majority is switched to a solid state overload or some type of motor protection and removed some of the old bimetallic heaters or so forth, or solder pots, as some guys have called, that have been around a long time. But with that said, now that introduces a true motor management system. Now I'm going to kind of step off on motor management systems here. Oh, I apologize. Real quick, here's a slide introducing the SIMOCODE into a motor control bucket or a control panel. It's kind of an eye chart, but what I want to emphasize with this is that with the SIMOCODE, it is your overload. It will measure your current, and if you want, it also will measure your voltage, so you can do phase loss or phase imbalance. but then it also has the ability to be your local control. Now I want to emphasize local, meaning your handoff auto could be right there at the motor control bucket because it has its own 24-volt power supply built in. And then you can power your stop and your start and your handoff auto right next to the SIMOCODE. Now, bear in mind, doesn't have a lot of amperage to try to drive something that's 15 or 20 feet away from it. This is more local of 5 or 6 feet uh, near it to like on a control panel door or an MCC bucket door. But this is introducing it. You can see you got your control power transformer up here. You're reducing the voltage. You can control and excitate the SIMOCODE at 110 to 240 volt. And then again, it has its own 24-volt power supply built in. And we'll show you how that's utilized here in just a few minutes more. But this is the introduction of SIMOCODE into this motor management system that we're showing you. And then again, the field bus, we'll talk about the communication protocols that SIMOCODE can do with an emphasis today, as you saw on the first slide, Ethernet IP. So to move on to the next slide, what can the SIMOCODE monitor? What can it give you? What information can you give you? Well, there's multiple things that we can do. We can do local measurement, or it can become a remote IO for you. And then with that, we can bring in raw values and analyze and give a complement to the motor management system with you. And we're going to show you some of that stuff. But the key to it is also the flexibility of that when we're monitoring and detecting, what do we do with it? What will be our response? So the flexibility with SIMOCODE is to be able to detect and then be able to customize our response to maybe some type of problem or just some type of maintenance requirement for preventive maintenance and so forth. But here's a list of some of the stuff that we can detect within SIMOCODE. Of course, as I stated, we can do overload. That's the basic properties of it. It is your overload. But then I can do monitor current and do current only if that's your requirement. But then I can also add or change the current CT to a PT-CT, which is your current transducer and power transducer in one. And now I can do phase loss, phase imbalance, and monitor the voltage. And then I can also now add to the basic SIMOCODE, I can add up to 6 RTDs and bring that into the SIMOCODE to where I can put them on a gearbox housing or a pump housing and be able to monitor the temperature. And in my previous life before Siemens, we have gearboxes that run stuff all the time. And there was a small little problem with gear lube not being placed inside of that gearbox.
Mm-hmm.
And it more or less, as everybody could say, it burned itself up and it was an expensive lesson to learn. But if they would have put just one RTD on the gearbox housing and then within the SIMOCODE set up a temperature limit, and said, once you reach this type of temperature, please trip and send an alarm to the operator to let them know that the gearbox is overheating, then we would have protected that. And that's where I want to talk about where SIMOCODE wants to protect the entire process that motor's turning, not just the motor, where that's what the SIMOCODE's sweet spot is to protect that entire process. And then of course, stalled rotor, we could do that if you're doing maybe a fire pump application. And then we also have time. I have another opportunity back a few years ago where a customer wanted to minimize how many times that pump was turned on, and he only wanted to allow 5 times in a half hour. And so SIMOCODE has the ability, it lays dormant, it doesn't turn on unless you want to, but you have the ability to put in how many times you want to have the motor turn on within a time period. And then if it exceeds that, let the operator know that set parameter is exceeded and the motor's not going to start until a cool down period or a resting period that is needed, or maybe even a spin down. So if you have the motor turning some high inertia and it needs to spin down for 20 or 30 minutes to allow it to stop before you change the direction. But then also we can get power factor, kilowatts per hour if we're using the voltage VT or PT for it, and give you all different types of events. But as I stated, I have the ability to give the best response of how you want to act and react to it. You could trip on them, you can warn, or we could do a signal. Now the differences are, signal means that I'm going to do some type of bit toggle, that I'm going to change it and have it go high from 0 to 1 and show up at the operator's panel just to let them know that, hey, this has happened. warning does the bit toggle, like the signal, but then it enunciates in the SIMOCODE if you have the operator panel, and then also the SIMOCODE has its own web page. And so it will enunciate in the web page to let you know that we have a warning condition. We're approaching something that you've set as the plant of something's going wrong or something's reaching a certain level. And then of course our trip. Trip also has a bit toggle. It sends to the web page, let it know that we have a trip, and gives you words and says overload, or here in a minute I'm going to demonstrate what I call uh, a fault that comes to if you have an execution stop command where you told the starter to stop, but it continued to have current flowing. But the trip, of course, means everything's going to shut off and so forth. But you have the ability to set those up yourself, and very, very flexible. Now, so here's kind of a quick little synopsis of Windows of how you can set it up. So you can see here that I'm giving a quick overview of how you can set it up to be a warn or a signal. And then there's a percent of current and trip levels. But this screen here, so some of you guys that are into the process side and also in the digital side of things, you also set limits. So what I'm showing is within the SIMOCODE, and if you remember in the slide previously, I talked about having some logic. This could be my high and my low that you usually put in as code in the PLC or the DCS system. So that means that the SIMOCODE can stand alone in a pump panel all by itself, and you can set up high and low current limits and have it trip on maybe a pump that's running some sprinkling systems, or maybe a small water pump for culinary, but it has all the capabilities of what you would use in a PLC for small projects standalone, or you can set these up to work in conjunction with the PLC or DCS system.
Now, for the audio audience who can't see this, what software are you using to configure this guy?
So the software for it is TIA Portal, which
Okay.
is our totally integrated automation portal. My analogy that I use with Portal to help people who've haven't encountered Portal yet is if I say Windows, let's say Office 365, then your mind usually goes to, okay, that's Excel and Outlook and PowerPoint
Mhm.
and so forth. But that Office 365 is the umbrella and kind of over the whole suite of software. Well, for this SIMOCODE, TIA Portal is the umbrella over the suite of software, and SIMOCODE is just an add-on to work in conjunction. If you want to do standalone for SIMOCODE, then that's all you use. Or if you already have Portal and you're using our drives or our PLCs, this is just an add-on that will come underneath that umbrella, and then you'll be having the ability to access the hardware and the configuration and so forth. But for a standalone project, like you're putting something in a pump panel and you've never used Siemens ever, the software will load. It'll look exactly like TI Portal. If you were a PLC guy or a drives guy, everything looks exactly the same. The menus, it's the same feel, function, the way it moves, how the screens look. And so once you become familiar with one software, then have overcome that learning curve for the other ones and start to go, oh yeah, I remember how to go online. You go online here with SIMOCODE. Oh look, it's the same going online with the PLC or with the drive, and so forth. So it's that same uniformity under that umbrella as the analogy I used with like Office 365. All right, so here's with the SIMOCODE. We're just going to show you kind of as I stated, kind of a standard cross the line starter application. You can see here that we've got a flow, valve, a filter, and we're measuring delta P across it. And then we have another valve, and then we got a tank with some sensors for lower and upper, and then also a float to tell them where approximately it is, and so forth and so on. But this is just an application of a standard starter. And if you look at it, yeah, it's an IEC starter. You can interject a NEMA starter here if you would like. But really, it's trying to emphasize that you're not getting any really major data to help you. And as you know, data is king nowadays. And I know a few major uh, applications out there that are looking for data right down to the IO point. But what we have here really is just an overload relay protecting the motor. And yes, you may have a sealing circuit or a contactor telling you that the three phases are pulled in. and saying that it's running. But then of course you see the flow, so that tells you that the pump's operating and there's no coupler problem between the motor and the pump. And then you have a delta P, and that's coming in, but it's going to all this IO that's out there. Now, if I introduce the SIMOCODE, what can it give us? Well, we're using the same communication protocol and as the IO, but now when I introduce the SIMOCODE and putting in the CT and make it my overload, now, and I'm using a PT, current transducer, and a power transducer, now I can give you current draw, voltage, phase imbalance, phase loss, kilowatt per hour, kVA, power factor. I'm not controlling it, but I'm reporting it back to you guys to let you know what's going on. And then I can give you statistical data, how many times the pump turned on, how many times it turned off, how long was it down for. I've gone into some facilities that if those pumps are not running, they're not making money. And so if the pumps are down longer than 30 minutes, they have literally a bit that turns on, sends a page to the maintenance manager, the plant manager, and the operations manager, and they need all hands on deck to figure out why that's been down for 30 minutes. Because again, if that pump's not pumping, the facility's not making money. Now, bear in mind there is scheduled downtime, but if that pump's at a normal run rate and then something goes down and it's not back up within 30 minutes, then the plant manager wants an all hands on deck to figure out what's going on. And it could be a great indicator for OEE to say maybe upstream is slowing them down, or they don't have the product there and it's stopping to wait for product to be caught up upstream, or maybe downstream and they may have problems where they have a bottleneck downstream. So this gives the ability to start refining your process because you're getting that statistical data and being able to use it to your advantage. Then with that said, I'm going to kind of introduce the SIMOCODE a little bit more. It's going to take over all that IO. And again, I'm kind of pushing this to the SIMOCODE's limits. It's reaching that with an analog module so I can see the flows coming in. Again, we're not controlling them because it's a cross the line starter. And then I'm able to see the delta P. And then I put a digital module, and now I can see the digital ins of the tanks, and I can do an output to that valve to open or close. And now the SIMOCODE is taking care of that entire application directly to the SIMOCODE. And now it'll be able to do a standalone if it needed, or it can continue to contact the PLC and give all the information that's going on there in that application. And then one last extension of that is the safety factor. So we can do safety depending on your application, but we can do any of the safety that is required with your plant. If you're using the safety specifications for SEAL, safety integrated level, SEAL level 1, 2, or 3, or if you're using the specification for performance level A, B, C, and D. I'm able to do that locally and with third-party PLCs, or with a Siemens safety PLC, we can do Profi Safe, and you have the safety. Now that unit that you see there to the yellow, that is my fail-safe digital module with working in conjunction with the SIMOCODE. It's mounted right next to it, and then it opens up the safety that is needed for e-stops, pull ropes, or so forth, whatever is required for your application. But just know that with SIMOCODE, I can do a standalone safety, and you don't need a safety PLC to make the motor there that you want be a safe application. It can stand alone and work with a non-safe PLC. Here's the history of SIMOCODE. It's not a new fandangled that's been out just a couple of years. It has history. It's been around quite some time. Like I said, I started with Siemens in 2006. And when I got hired, I started going through all the catalogs, trying to get to know all my product and so forth. And SIMOCODE stands out for me because it's just so flexible and can help guys with a lot of problems in their processes. And so I've always enjoyed talking to customers about these. There's so many other products too, but this one really stood out for me. But notice that we started it initially in 1996. And if you look at it really close, that unit there has the CT and the brains all integrated into one piece. So if eventually the brains, because there are contactors in this, wore out, then you are unwiring the motor leads. And then you're, of course, undoing all the control wiring too to replace it. In 2004, we switched up the form factor to where now the CT and PT is a separate unit. It is not integrated to it. So because we have customers that say, hey, if we switch this out, we have people that are swapping phases. So then the motors go in the opposite direction.
Oof.
So we don't want to touch that. And we're like, okay, no problem. And then we took it to the next level. And if you look closer to the SIMOCODE at a time, you'll see that all the terminal blocks are removable. So once you've installed it, it's been commissioned, you never have to unwire anything. You just unplug the communication protocol, you undo the terminal blocks, you unplug the CT, and then you can replace the SIMOCODE unit and plug in the same terminal blocks, and you never have to unwire anything. And that's 99.9% of the time. There is a few exceptions to that, but 9%, 99% of the time, it's just remove terminal blocks, replace the unit, plug it in, and then now the hardware's all ready to roll, and you didn't have to unwire anything or worry about the loop checks again and so forth. And then again, safety in 2011. Then we went to the TCP/IP protocol, Profinet. The Pro S is a unit that's been around. That's mostly in Europe. We have a few applications here in the United States that use it. And then notice in 2015 we came out with RTU. And then in 2017 we've been talking Ethernet IP. And then in 2018 we came out with a little more cost-effective unit to where that it only measures current, and it has the ability to expand one card, meaning I can expand a digital module or a current module, or pardon me, a analog module, but that's it, one card. With the full-blown version, the Profinet Pro V, you can expand 2 digital cards, 2 analog cards, 2 temperature cards, up to 7 modules. Wow. And be able to expand. But with the GP, to make it a little more cost effective, it's only able to expand 1 module. So quickly, we'll just kind of go through. Here's kind of the basic setup. As I stated, the basic unit is your CT module. Let's just, for our discussion today, let's just say that our customer wanted to monitor his voltage and current. So you can see it's a little bit of an eye chart, but L1, L2, and L3 is right there in the front. That's where you wire in the voltage. And then the current for this CT module is a pass-through, where you feed the wires through. We do have a bolt-on version. And then there's a cable, and then it goes to the basic unit. And that's where the brains of this system is. So a bare bones system would have a basic unit, a cable that you would communicate to the CT, and that's it. Everything else, the expansion modules, digital modules, the operator panel that you see here, those are totally optional. They're not required. And so the basic module and setup would have 3 part numbers: cable, CT, PT, and then the basic unit. And we're off to the races. So let's talk about that just a little bit more. Here's the breakdown of the SIMOCODE. It has 3 relay outputs that can handle up to 240 volts, 3 amps. Then it has 4 binary inputs, 24 volt DC. So that could be your handoff auto, your start stop switch coming to it. And then if you remember right there at the beginning, terminal block 8 is a 24 volt power supply, and you could wire all your inputs through that locally at the panel, nothing real far away. Then you have a thermistor. Some customers I ran across too, they put a after 150 horse motor, they'll put a thermistor in the stator. And then the communication protocol to talk to the other modules is RS-232. And then, of course, we're emphasizing today the TCP/IP protocol, Profinet, and Ethernet IP. There's a 2-port switch that you can use there, and it's a dumb switch. It can allow you to do star topology, token ring, or if you want, don't recommend it, but if you want to just do daisy chain. So, and then up underneath is where the current transducer or voltage transducer plugs in. And then you can see that there's 2 voltage excitation voltages for it, 110 to 240 volt or 24 volts DC. So quickly, so we can get into the heart of the things. The number 2 things you need to do is select the base, what voltage, what communication protocol you want, and then what amperage you're going to use for it. And then everything else is optional. The operator panel is your fluke meter. This day and age with arc flash, you don't want to open up a cabinet. Everybody's kind of leery about that. So if you're standing at a motor control panel or an MCC, you're able to look at that, use that operator panel as your fluke. You can see the current draw, you can see the 20 trips that's happened, you can see the inputs and outputs coming in from maybe the DCS and see the statuses. You can see that maybe your local handoff auto, and you can test and say, okay, I'm pushing start. Oh, yeah, I don't see the input changing state. So that means maybe my contact's bad. And then you can go, well, open up and change the contactor on the push button. And then we have the IO modules for analog, digital modules. As I stated, the inputs for the SIMOCODE is 24 volts DC. There's many customers out there that still do 120 volt control. So we have a digital module that would add to that accessory and be able to use the 120 volt inputs for it. Quickly, here's kind of the part numbers. As we stated, it are the four main communication protocols that it does is Ethernet IP, Modbus RTU, Profibus, and then Profinet IO. And then you can see here the general purpose ones that I talked about with a little more cost effective. That's the Profibus and Profinet. But again, the web page and the OPCUA server still available in the lower cost, the general performance one. It's not just in the high performance SIMOCODE. Here's the CTs. Again, we have a spectrum of current that ranges. So it shows the ones that are feed through CTs up to 200 amps. And then we go to bus bar connections from 20 to 200 or 63 to 630 amps. And then you can see down below is the current / voltage measuring modules, and you can see where they offer there. And then the cabling. To talk to the basic unit, I can go up to 2.5 meters away to where you can put your 480 volt on one side of the cabinet, and then your 110 to 24 volt on the other. And then you can look at your arc flash and your PPE for that opening which side of the cabinet and help be able to just to stay on the lower cal PPE that you need because you're only opening up to 24 volts or 110. And then again, the operator panel, and that's your fluke meter. It can be used as a handoff auto. And then here's the additional add-ons that you can do with it. As I stated, there's a digital module for 110 to 240 volt. So if you are using control voltage in that higher AC, DC ranges, it's capable of doing that because of the basic unit only doing 24 volt DC. And then the higher performance, I can go and increase more cards to where we expand that out and add a lot more digital ins and digital outs. Now, as I stated earlier, we changed the hardware out pretty quickly. The CT doesn't need to be unwired when you're replacing the basic unit. Over time, there's 3 relay contactors. They will wear out over time. And then the terminal blocks are removable. But the basic unit also needs the software that goes into it. So we have 3 main ways of programming them. And I'm going to just speak to it now as if they were already programmed and you're a maintenance guy and you're going out and swapping one out because it's not pulling in the contactor and maybe that contactor inside the SIMOCODE needs to be replaced. So once I've done the mechanical side of things of replacing it, it's DIN rail mountable. So you remove the cable for the CT, remove the terminal blocks, lift it off the DIN rail, grab the new one out of the box, remove its terminal blocks, snap it on the DIN rail, plug in the existing terminal blocks, plug in the CT, and mechanically it's ready to roll. But it needs to be programmed. So we have the 2 things you see in front of me. We've got a little memory module that holds the configuration in it where you would plug in. Once you're done swapping it out, cycle the power, and then the memory module sees that there is no configuration inside of it, so it dumps the configuration that it has in the memory module, and you're up and running. Or our motor control center brethren, they have what we call an initialization module. They go off, and that one is mechanically drilled into our wireways, so that if somebody racks out an MCC bucket and they rack in a new one, the initialization module, as soon as it sees power, it will dump the configuration into the SIMOCODE and they're up and running. And the key to that is that it's mechanically tied to that space. When it comes from our motor control center facility, it has a self-tapping screw that ties it into the hardware so nobody can walk away with it. The downside of the little memory module is that the SIMOCODE doesn't need it to run. So once they've downloaded it, they could pull it out, put it in their pocket, and walk off. And that's a little bit of the downside, the pros and cons of it. Or you can just leave it in the SIMOCODE and so forth. And then, of course, the third way is using a laptop to program it once it's connected to the communication protocol. So software-wise, I talked about it being programmed. The basic software for it, there's 2 versions. The basic is required for programming, and it is free. There's no cost to it. And you'd use a cable. There's a specific cable for it. It's an RS-232 or a USB cable that you plug in. And then the professional software for it, and this is the TIA portal that I talked about, the add-on, it has a lot more parameters. It has some more capabilities for startup and so forth and so on, to where you're able to do a quick startup in multiple buckets or multiple motors and give you the tools to be able to start that up. Some of the tools that it comes with the professional, if you see there about 3/4 of the way down, is the CFCs. There's a CFC certified function chart application where you can see all the inputs and outputs coming into it and so forth. And Shawn, that concludes my presentation for part 1 of this. And now we'll go on with part 2 here in a little bit. So thank you for having me here, Shawn. Appreciate it.
Well, Mark, I really appreciate you coming back on the show and going through SIMOCODE to tell us all about what it does. And I'm excited for our next session together where we'll actually do some hands-on. And I think you're going to do both Studio 5000 and TIA Portal. So I'm really excited, and I'm very much looking forward to that.
Thanks again, buddy. Have a great day.
Well, I hope you enjoyed that episode. I want to thank Mark for coming on the show and bringing us all up to speed on the SIMOCODE product line. Now, if you want to catch the hands-on demo he does for me, check out the next edition of the Automation Demo Show. With that said, if you did enjoy this episode, please consider giving us a like and a sub. And if you want to follow me or keep in touch, you can do so over at automation.locals.com. You'll also find all my training courses over at theautomationschool.com. And with that, I want to wish you all a very happy, safe, and healthy week. And until next time, my friends, peace.